So hello everyone. In this video, I'll be demonstrating about how to run the source code from the chapter about microprofile fault tolerance from microprofile API tutorial version 7.1. So here to execute, I will go to the code folder. I've already cloned the repo. So just to kind of give you a understanding what it is all about. So we have a microprofile API tutorial. This is version 7.1. In this, there is a chapter 8, which is about fault tolerance. In this, we have covered various topics about different fault tolerance patterns, including retries, including asynchronous calls, circuit breakers. We have topics about timeouts, fallback, retries, bulkheads. So all the patterns are covered and they are described well here with the help of diagrams wherever possible or with the help of source code snippets. So you can read the details from this particular chapter. And along with this chapter, we have the sample source code, which readers can try out to understand the tutorial better. So now I'm changing to the directory chapter 8 because chapter 8 is the chapter which is about fault tolerance. In this, we have a microservice which is payment microservice. This simulates external call to payment gateway. And here we have implemented various features of fault tolerance patterns to make it robust and resilient. And this source code will demonstrate different patterns ranging from asynchronous calls, timeout, fallback, circuit breakers. Then we have bulkhead. So all 6 fault tolerance patterns have been demonstrated here. So now as we are within this folder, we will see there is a pom.xml. So within the payment directory, we will have pom.xml, as well as we have various test scripts as well. So first let's run the payment service. So within the payment service, I'll run this command, which is mvn clean package. And I'll run the Liberty server in development mode. And then from a different terminal, we will try out various test scripts to demonstrate the execution of the payment service. And then we will also see various implemented fault tolerance patterns. So let me come back to code and then chapter 8 folder. So just getting into this, and then I am going inside my payment folder where I have all the test scripts. So now let's see what is the status of our server. So we see that the server has been launched successfully and our application is running. So we see that this is running in 9080 port, 9080 port. We can see this in action also. So here we have various features implemented, and we have also OpenAPI implemented. So let me open this service, which is running on 9080 port in browser, and then we will be seeing execution of so let's open this in browser. So open in Chrome. So this is the default page, and then we have OpenAPI documentation also available for the payment service. So this is some redirection which is happening. So let me avoid this by using another endpoint. Yeah. So now you see here, this is my payment service. We have the server here. We have here the description of various APIs, and these all APIs will simulate different patterns, fault tolerance patterns, and they will also simulate error conditions. So there is a random and sleep and different simulations which are added in the source code, which is for simulating error conditions. Now let's come back to our terminal, and let's try out the commands. So there is a method which is called authorize payment. This is simulating the processing of payment in external payment gateway. And then we have various test scripts. So let's first test about asynchronous pattern. So I have test payment async.sh. This is a test script which will test this APIs through command line calls using curl command, and then you will see that no, there is a report which will be generated, and you will see the execution of all these APIs in command line in very well described console logs. So here we see that, okay, send payment notification method is there, which is designed to be asynchronous, and we have made a call first, a synchronous call which took 2.368 seconds. Then we sent sequential asynchronous calls. So here you see that, okay, there have been a lot of calls which have been sent, and we have sent the concurrent calls as well. So this will demonstrate asynchronous call for an API. So now let's look into another test method, which is test payment. So let me do an ls first to show you various commands. So let's say first test payment basic, and we have to put the extension as well, which is .sh. So this is the basic test for payment API. Here we are calling payment config, so it will return the payment config API. So here this is a simple test. We have a payment authorization call also, which has retry, timeout, and fallback all implemented. So it took various retries, and then it returns the result. So here we have 60% simulated failure rate. So retries will fail when there is a failure. And sometimes there will be fallback method as well. So this is how you will execute and see this payment API in running. So now let's try the retry.sh method. Now, very interesting thing, we can also check the matrices around fault tolerance. So matrice is another very important observability feature. So this has also been demonstrated in these examples. So now when I run the retry test, you see there have been different runs of the API, and we see that the APIs have been called with different values, different parameters, and sometimes it's executed in first attempt, and then sometimes there are no retries, there are some errors as well. So these are various tests, and some random amount of tests are also run. So here you see there have been 3 retries, So this is color coded and with symbols, very well formatted test report. And there have been 2 retries in this particular case. So there have been multiple calls of this API which has been made, and then finally you see the telemetry result in the Prometheus format also for monitoring and for observability tool. So this sample code not only demonstrates fault tolerance, but it also demonstrates integration with matrices, and it also demonstrates integration with microprofile configuration. So you get a complete overview of this particular fault tolerance specification in MicroProfile 7.1. So now let's execute some other scenarios. So let's talk about, so we have seen payment basic test, we have seen payment asynchronous call test, we have also seen test about retry mechanism. Then let's see the call about circuit breaker. So let me execute payment and circuit breaker test as well. So in this particular circuit breaker test, we have a threshold set for 4, and if there is a failure ratio of 50%, then the circuit breaker will go to open state. And then if there are 2 consecutive successful calls, it will open to half open state, and there is a timeout also. So these are various scenarios. We have some random failure rate as well. So when we hit enter, it will start running the test. It'll make multiple calls repeatedly, and you will see that there will be circuit breaker which will be in open state, and then it will go to different stages as well, and then it will allow you to even go and come back to the closed state as well. So this is a demonstration of circuit breaker pattern, and then you see here telemetry information is also shown. So this is all about the source code of circuit breaker test. Now let me show you other test cases, which is around bulkhead. So now when I go to the bulkhead test, we see, so let me go to and execute the bulkhead test. So test payment and bulkhead. So I've executed the bulkhead test. It will run the request in different batches, and you will see that, okay, bulkhead is full, and then it will also demonstrate the bulkhead queue as well. So both semaphore based as well as thread pool bulkheads are demonstrated in this test script. And then you will see at the end the Prometheus formatted matrices also, which could be seen for monitoring purposes. So these are all the patterns which have been demonstrated. So yes, fallback pattern was also used in some of the source code. It is not demonstrated very explicitly, but it is demonstrated with other patterns. And then there is one last test which combines all circuit breaker patterns in single scenario test, so which is called concurrent load.sh. So if I run this, it demonstrates the retry. Retry is also having fallback, and then circuit breaker, and bulkhead. So these are all the scenarios which will be seen in this particular test case. You can read more about these test scripts in the README file. So you see here there was fallback also demonstrated here because in one scenario there was an error and there was a fallback. Then we have here health checks, and health checks are used for here opening the circuit breaker and closing it. So this is a demonstration of the circuit breaker pattern. Then again, there is async feature and bulkhead demonstrated together. So you see that as well. So this is the entire test which will combine various fault tolerance patterns and demonstrate them within a single test script, and then finally we'll display the matrices in the Prometheus format. So this will give you comprehensive understanding of fault tolerance. So that's what I have right now for this particular fault tolerance chapter, because we have now demonstrated all the features, have seen them in working. So you can play around by following the steps in this video, and share your inputs, comments, or any feedback in this particular video.